Hey guys, so this week we're going to be utilizing what we did last week with nets, but this week what we're going to be doing is the surface area of a prism. So when I talk about a prism, I'm generally talking about either a rectangular prism or a triangular prism. There were three objects that we looked at nets for. One was our rectangular prism, where all sides are based on rectangles or squares. Oh, that's awful. Let me try that again. Holy. There. That's better. Or a triangular prism, where we have triangles as what we call our base shape, and then rectangles around the sides. This doesn't have to look like this. It may even be standing up like this. But we call this our base shape. We did also look at cylinders, but because surface area takes a little bit for us to be able to calculate, I'm not going to go over the surface area of a cylinder until next week. So, to figure out the surface area of a prism, the first thing we need to do is draw the net. So say we're given a rectangular prism. And we're given it with the measurements of 6 centimeters, 10 centimeters, and 4 centimeters. Well, our first thing to do is draw our net. So if I'm looking at this with this front part being here, means that the back part is also here. Means the height is going to be 4, which means this height's going to be 4, this height's going to be 4, this height's going to be 4. This bottom piece here is going to be our 10, which means this is 2. If you look, when we fold this into a shape, this bottom piece here is actually going to be this height, which means that is 10. And if this is, say, our bottom, then this has to be our top, which means it'll have the same measurements. Which means if this is our side, this will be our other side. And this will have the same measurements as before. And our last measurement is this length in between, and that's going to actually be our width, which is 6, which means every single one of these lines is going to be 6. So to figure out surface area, what we have to do is we have to figure out the area of each of these rectangles and add them together. So to find the area of a rectangle, it's length times width. So I'm going to do this in a different color. If I have 6 by 4, that is going to be 24. This one is 10 by 6, which gives me 60. We have our 4 by 6, which is 24, and our 6 by 10, which gives us 60. And then our last two Our last two, this one here and this one here, is our 4 by 10, which is 40. So if you look at something, we have 24 and 24. We have 60 and we have 60. And we have 40 and we have 40. Which is exactly what we were talking about the other day. The front will be the same as the back, the top will be the same as the bottom, and one side will be the same as the other side when it comes to a rectangular prism. Well, to figure out the surface area, we have to add all these together. So 24 plus 24 plus 60 plus 60 plus 40 plus 40, which will give us 248 centimeters squared. And we have to do centimeters squared because we did length times width. So we did 4 centimeters times 6 centimeters, which was 24 centimeters squared. We did 4 centimeters times 10 centimeters, which gave us 40 centimeters squared. And we did 6 centimeters times 10 centimeters, which gave us 60 centimeters squared. So all of these are centimeters squared because they're area, so our answer is centimeters squared. If we have a triangular prism, it's similar. But there's two main types of triangular prisms that you'll encounter. There's one where you'll be given the height, so you'll be given that this is 2.6 meters. The base is 3 meters. And this length here is 9 meters. And you'll have to figure out the surface area. Very first thing we do is draw our net. So for this one, we're going to have 3 rectangles. And the height of each of these rectangles is going to be 9 meters. So each of these lines is 9 meters long. This base here, across here, that is going to be our 3 meters. So it'll be 3 meters here too. But we can't necessarily assume that the other ones are 3 meters. What we actually have to do is, using this 2.6 meters, we actually have to do Pythagoras to find out what this height is, or what this hypotenuse is. So half of 3 is going to give us 1.5. So we'll have 1.5 squared plus 2.6 squared, and that will give us our side length squared. So 1.5 squared gives us 2.25. 2.6 squared gives us 6.76. So when we add these together, we get approximately 9.01. Remember, the last step is to square root that, and that will actually give us a 3. So this distance is actually our 3, which means this one is 2, which means these sides are also 3 meters. Sometimes you'll see where they will have a line through each of these, and when you see a line like this, it means that they're all 3 equal lengths. So now we have to determine what the area of each shape is. Well, to find a rectangle, we already know the area of a rectangle is length times width. So 3 times 9 gives me 27 meters squared. 3 times 9 gives me 27 meters squared. And 3 times 9 gives me 27 meters squared. For a triangle, it's a little bit different. Its base, which is the length along the bottom of the triangle, times height, which is the height of the triangle, but then it's divided by 2. So for us, our two triangles are going to be 2.6 times 3 divided by 2. So that gives us 7.8 divided by 2, which gives us 3.6. Which gives us 3.9, meters squared. So this is 3.9, this is 3.9. So now we have to add them together. So the surface area of a rectangular prism is going to be 3.9 plus 3.9. And our triangles will always be the same for these. Plus 27 plus 27 plus 27. So our rectangles are only the same because our triangle was an equilateral. If the sides of the triangle are different, then the sides of the rectangles will be different. So if we do 3.9 plus 3.9 plus 27 plus 27 plus 27, we get 88.8 meters squared as our answer. So another type of triangular prism you'll see has the same steps for the most part, but it doesn't give you the height separately. It actually gives it to you as part of it. So if we had this shape and we said that this was 9.9, this it will actually give you the height as part of the shape. So if we have this is 7 centimeters, this is 7 centimeters, this long length, which would be our hypotenuse, is 9.9 centimeters, and this width is 2 centimeters. Well, the first thing we do again is we draw our net. So we're going to have 3 rectangles, but they're not necessarily all going to be the same size. They're relatively skinny because this width is only 2 centimeters wide, because that is the width from the front to the back. Then we have a longer one, which is our 9.9, and we have 2 shorter ones, which are our 2 7s. We still need our triangles though, and if you look, our triangles are going to look like they're the same height. This is 7, this is 7. this is 7, this is 7. So again, we need to figure out the area of each of these. So if you look for our triangle, our height is 7 and our base is 7. So the area of our triangle is going to be 7 times 7 divided by 2. But how many of these do we have? We have 2 of these. So when we're looking at the surface area, we're going to have 24.5 plus 24.5. Okay, now we look at our other ones. We have 2 times 7. It's 14. Again, 2 times 7. That'll give us 14. So we have 2 14s. And that only leaves us with this one in the middle. This one is 9.9 times 2. So that'll be 19.8. When we do 2 times 9.9. So as you can see, because our triangle wasn't equilateral this time, we actually had rectangles that had different areas. So 24.5 plus 24.5, that gives us 49, plus 28, plus 19.8, so that will actually give us 96.8 centimeters squared. So today's assignment, or this week's assignment, you're going to be practicing drawing with rectangular prism and triangular prism nets and calculating the surface area. So the questions are on page 54, and the questions are numbers 1, 3, 5, 8, 10, and 13. If you have any questions, please send me a message on Remind or on my email, or attend either of the Zoom meetings this week. I hope you guys had a great long weekend. I hope you have a great week this week, and I'll see you guys later.